This comes out of section 5.5, procedure for curve sketching. And the function we have here is y equals x squared over 1 minus x squared. So again, if I start with the domain, as the non-calculus stuff, I can see that if I factor that denominator, 1 minus x times 1 plus x, that x can be anything except for plus or minus 1. So something's going on at plus 1, minus 1. We'll look into that more in a second. For intercepts, if I let x equal 0, I can have 0 over 1, which is 0. So this graph goes through the origin. And if I try to let y equal 0, the only way that that's going to be true is, again, if x is 0. There's no other factor in the numerator there that's going to make that happen. So 0, 0 is my only intercept, and it's an x and a y intercept. Now when I talk about symmetry, since both x's in this equation are being squared, we do have even symmetry, meaning that if you put in a negative number for x, you get the same answer as if you put in a positive number, since you're squaring them, which will help me with my drawing later on. And now when I look at the asymptotes, if I do the limit as x approaches 1 from the right, the limit as x approaches 1 from the left, and the same thing for negative 1 from the right and from the left, I can decide whether these are going to be vertical asymptotes or not, which is often the case with these non-permissible values. And so if I put in, x squared over 1 minus x times 1 plus x, if I put in a number just to the right of 1, like 1.0001, I'm going to have a positive number divided by a tiny negative number times a positive number, and this thing will go to negative infinity. So I'll, just for the sake of time, I'll do the other three quickly here on pause. So I do find that I have vertical asymptotes at 1 and at negative 1, and I can see also whether I'm going to positive or negative infinity. So as I approach 1 from the right, I'm heading to negative infinity. As I approach from the left, I'm heading to positive infinity. Similar situation as I approach this other asymptote from the right side and from the left side. So this will help me with my drawing later on, and it should agree with some other stuff that I discover when I go to do my derivatives. So now my next job is to deal with first and second derivatives, so that'll take a few seconds as well. So I get this from my first derivative, 2x over 1 minus x squared squared, the important or critical values there being 0, 1, and negative 1. So I want to take a look and see whether I'm increasing or decreasing in those intervals. The good news about the denominators, it's always positive, so really I'm just looking at the numerator saying, well, if it's negative, if it's negative, if it's positive, it's positive. So I have decreasing intervals everywhere from negative infinity to negative 1, and from negative 1 to 0, increasing from 0 to 1 and 1 to infinity. Now let's go on to the second derivative. So we'll work with quotient rule and chain rule, some factoring. You end up with this. You only have two values of interest with the second derivative where it might be undefined, or where it is undefined. There's nowhere where it equals 0. And we can check some numbers here to see whether we're concave up or concave down. If you take a look with a number to the left of negative 1, negative 10 or something, for instance, the numerator will be positive, the denominator will be negative, so you'll have negative, and so you're concave down. In between negative 1 and 1, you could try 0, and you'll end up with concave up, it's positive, and then back to concave down. So those aren't points of inflection, but they are places where the concavity can change at those vertical asymptotes. Now I missed a step earlier when I was talking about asymptotes, where I should have said, what's the limit as x approaches infinity of this function? And if I go back to that for 1 second really quick, I'll find that if I divide everything by x squared on the top and on the bottom, I get that this equals negative 1, and you actually have yourself a horizontal asymptote at y equals negative 1. So please label your asymptotes y equals negative 1, x equals 1, x equals negative 1, so you have vertical and horizontal asymptotes. This graph needs to be approaching that and concave down and decreasing for all of this interval, so that agrees with that piece of the picture. It needs to continue decreasing but be concave up, goes through its y-intercept, x-intercept at the origin, stays concave up. So it does have one what you'd call a minimum point, local minimum, and then it is concave down again and approaches its asymptote. So the curve sketching problem it's pretty involved, especially if you're asked to do all of it. Reality is most test questions ask you some piece of it, maybe look at its concavity, or look at its max min, or look at its asymptotes, but there's one where you go through the whole procedure.